Hi guys, in this particular video, we are going to discuss about credit card fraud detection. So first of all, we have to import some important library. One is the NumPy, another one is the Pandas, and there is the trend display that we have imported from that scikit-learn model. And I'm trying to perform a logistic regression operation. For that reason, I have imported logistic regression from scikit-learn. And of course, I have to check that accuracy score. That's why I have taken again the accuracy score. Now, this data set is available in Kaggle. If you want, you can go through the data set from that Kaggle. The dataset name is the credit card fraud detection. Now, I want to check the first 5 row. How I will check? Using the head, it will give the first 5 row. Now, there is the time. Time means the transaction time. There is lot of another parameter, but this is very confidential. So what data we got here? The data it is after performing the principal component analysis. So that V1, V2, V3, V4, we can't tell exactly what is it. Okay. And there is the amount. There is the amount and class. Class means the legit or the fraud. The legit means that is the 0 and the fraud means the class is 1. I hope you understood the data. After that, I want to check the last 5 row. For that, I have to use the tail. For that, I have to use the tail. Now, I want to check the specific information from the data set. So, there is one important method in Pandas, that is the info. We have to use that. After that, here, I want to check how many missing values is there. How I'll check how many missing values is there or not? Again, using that is null dot sum. And it will give how many missing value is there. Now, fortunately, you don't have any missing value. If you don't have any missing value, then there is no point that you have to handle it. Okay. Otherwise, we have to handle that missing value. Here, I have checked in this particular data set how many legit transaction and how many fraud transaction is there. So, after seeing the data set, we can conclude that the data is highly imbalanced. Why? Now, the fraud transaction is less compared to the legit transaction. So the data is completely what, guys? Completely unbalanced data. Okay. Here 0 means the normal transaction and 1 means the fraudulent transaction. Now here, I am trying to separate the data for that analysis. One is what? One is the legit and another one is the what? Another one is the fraud. Legit means it is 0 and fraud means it will be 1. Now I'm trying to print the shape of that particular legit and fraud. Okay, so again we got some data. that is imbalanced. Now, we'll check the statistical analysis. If you write the describe, then the statistical analysis things will be coming. Here, from that particular data, I have calculated the 25 percentile, 50 percentile, 75 percentile, min, max, count, standard deviation. Okay. Now, same thing we will do for a fraud. Okay, we have to do for a both. We have to do for a legit as well as the fraud. Now, here, I want to check the mean. I want to check what, guys? The mean. And I want to compare the values for both transaction. So, that's why I have to use the group by. Now, the thing is that I have told before the data is what? Now, this is the undersampling. This is the imbalanced data. So for that imbalanced data, we have to do the undersampling and the oversampling. In my case, the fraudulent transaction is 492. So first of all, what we'll do? Here, we'll take another variable that is the legit sample. And we have to perform the undersampling. How we will perform the undersampling? See, here I have mentioned n equal to 492. Previously, what was the value of legit? See here, there is the something 2,84,315. Now, if I'll do the undersampling, and after that, if I'll concatenate two data, the legit sample and that fraud, then the things will be normalized. And here, guys, see, again, I'm trying to count the value. Now both, previously it was high, one was high and one was low. Now both are equal. So we have to perform why, guys, the undersampling, because I want the balanced data. Okay, I want the balanced data. Now the catch is that again we have seen the mean separately. Then we have to split the data in the training and text and the testing. Here in the training, I have dropped the class and I'll add this class into y variable. In that x, I have dropped the class and I have added this class into that y variable. And I got the updated result here. Now, I have to split the data into training and testing part. In the training part and testing part, I will divide the data into that 80-20 ratio. For this reason only, I have given here 0.2. Why? That is the 80-20 ratio. Now, I have checked the xtrain and xtest same. Then I have used the logistic regression model. Why logistic regression? No. What is the reason? The problem is like a classification problem. So we have to use what? The classification algorithm. That is one of the important classification algorithm is the logistic regression. Now in that way, I have checked the training data accuracy. The training data accuracy is what, guys? The 0.95, almost 95%. And as well as I have checked the test data accuracy. The test data accuracy also 93%. So in my data, the training accuracy is also good and the testing accuracy is also good. That means the model is perfectly trained, and it is giving the output. Thank guys. This is the practical implementation of fraud detection. Thank you, everyone.